Hello students. So let's solve another question based on the projectile motion. In this question, what they have given, a hiker stands on the edge of a cliff 490 meter above the ground and throws a stone horizontally with an initial speed of 15 meter per second. Neglecting the air resistance, find the time taken by the stone to reach the ground and the speed with which it hits the ground. Okay. So first of all, uh, here in this case, what they have given, we can say the projectile is not starting from the ground level. Initially, it is situated at some height, and that height is nothing but it is 490 meter that it is given here. Okay, so now this question is like the coordinate axis will be same, y-axis, x-axis, and now this time that stone is at some height, okay, at this height h. For example, I'm writing here the height is at as it is given 490 meter from the ground. And now it is now the stone was thrown with some initial velocity 15 meter per second with the horizontal velocity. Okay, so the horizontal velocity is ux equals to 15 meter per second. Now what they are asking to find out the time taken by the stone to reach the ground. For example, that stone is reaching at this point. So here, what will be the height, or what will be the, we can say, y coordinate of that, y coordinate of the stone? It will be 0. Okay. So we will apply Newton's second equation of motion. Here, basically, first of all, we should write the initial velocity. Initial velocity. So they are saying that the stone was thrown in the horizontal direction with some initial velocity 15 meter per second. So there will be no, we can say, vertical velocity. Okay. Or we can say the vertical component of the initial velocity. So let us write ux will be 15 meter per second and uy is 0 meter per second. Now apply Newton's second equation of motion. Okay. In which direction? In y direction. So if we apply the Newton's second equation of motion in y direction, what is the Newton's equation of motion in y direction? It is basically y minus y naught equals to uyt plus half ay t square. Okay, where uy is 0 as we can see, and ay is nothing but minus z, or we can say minus 9.8 meter per second square. And for the first part where they are saying that what is the time taken to reach the ground. Okay, so when the particle will reach at the stone will reach the ground, and the stone will reach the ground, what will be the y coordinate then? It will be 0. And here the y naught is the initial y coordinate. So initial y coordinate is nothing but 490 meter. So here y naught is 490 meter. Okay. So now we'll put this in the equation, above equation. name it as equation 1. So from equation 1, what we can write from equation number 1? We can write that 0 minus 490 equals to 0 into t minus 1 by 2 into 9.8 into t square. Because you can see that here the value of y is 0 and the value of y naught is 490 meter and uy is 0, and here 1 by 2 into ay is minus g, that is minus 9.8, and t square is t square. Now the equation will become as 4 minus of 490 equals to this 0 into t is 0 minus of half 9.8 t square. Now this minus and minus will be cancelled out and the 2 will be multiplied with 490, and what we will get, 490 into 2 upon 9.8 equals to t square. Now our task is to uh, multiply 2 with 49 and it will be 98. So it will be 98, or we can say 980 because 0 is also there. So 980 upon 9.8 equals to t square. Now if we divide 980 by 9.8, what we will get? We will get 100 equals to t square. And if we will take square root both of sides, so we will get square root of 100 is 10. So the time taken to reach the ground will be 10 seconds. So here the first answer is, or we can say answer for the first question is, wait, answer for the first question is t equals to 10 seconds. So the particle or the stone will take 10 seconds to reach the ground. Now the second part, in the second part, what they are saying? In the second part, they are saying that the speed with which it hits the ground. Okay. There are two things. First of all, the velocity is in two components, y component and x component. And we know that in x direction, there is no, we can say, acceleration. So the x component of the velocity will be same, and but the y component of the velocity will change. That will we are going to see now. Second part of the question. Now we will apply Newton's which equation? First equation of motion. So first of all, we will apply in the x direction. In x direction, the final velocity we will write as vx, and the initial velocity is ux plus ax into t. This is the equation in the x direction. Now we know that here ax equals to 0 meter per second square, because acceleration in the x direction is 0 for a projectile. Now the equation will become as vx equals to ux, and we know that it was nothing but 15 meter per second. Now in y direction, the equation will be vy equals to uy plus ay into t. Now, as we already know that here uy is 0 and ay is minus t. So that's why the equation will be here uy is 0 meter per second, and ay is nothing but minus g, or we can say minus 9.8 meter per second square. Now the equation will be Vy equals to 0 minus 9.8 into t. Now the time t that we derived is nothing but it is uh, 10 seconds. Okay, so we will put the values. So we will get equals to minus 9.8 into 10 meter per second. Vy equals to minus 98 meter per second. So this is the final velocity in the x direction 15 meter per second, and Vy equals to minus 98 meter per second. Don't worry about the negative symbol because we know that or we can say with respect to its initial position, the particle is moving in the downward direction, that will be in the negative direction. So that's why. So here, or we can write in the vector form also, what the velocity can be written as. So velocity can be written as, one second, the velocity of the stone at the time and it touches the ground. Touches the ground. What it will be? It will be V vector equals to, it will be V vector. You know the vector quantity? Okay. So V vector will be Vx I k plus Vy j k. Now V vector will be 15 I k minus 98 j k, and the unit will be meter per second. So this will be the final velocity. And what they have asked, speed. Okay. So we know that velocity contains magnitude and direction both. So here it is containing the direction 15 ik minus 19 jk. So for speed, what we are going to take? What we are going to take the magnitude of the velocity. So here the speed will be v equals to magnitude of v vector, that is nothing but v equals to vx square plus vy square. Vx square plus vy square. Now we will put the values, and it will be 15 square plus 19 square. And as we know that we are determining here the speed, so the unit will be meter per second. Don't forget to write the unit in the numerical question because otherwise it will be wrong. Now the 15 square, that we know it is 225 plus, let me see, the 9 square of 98, it will be 9604 meter per second. And finally, if we add it with 225, it will be 9829 meter per second. And if we take its square root, then it will be approximately 99.14 meter per second. So this will be the final velocity, final speed at the time when the stone will touch the ground. Or sometime what you can see in your textbook, it is written as 99 meter per second. So that is, we can say, most we can say the nearest integral value. Okay. Or we can say the nearest whole number. So sometimes it is written as v equals to approximately 99 meter per second. Both are correct. If you care about the exact calculation, then it will be 99.14. And if you are finding out the roughly, or we can say approximate value, or we can say the round off value, then it will be 99 meter per second. Okay. I hope you understood this question, or like if you have any doubt, then you can ask in the comment section. I'll be happy to answer.